What's up, YouTube? So, we are going to have a lecture class on the very basics of Marlin, which involve a few things. So, the first thing you should do is technically you should go over to that YouTube page and watch some Chris Riley videos on Marlin 2.0. Um, he has some excellent videos to get you started, and you can learn some, uh, you know, specifics to that. There's also teaching tech. I forgot to grab his YouTube link. He's also got a bunch of Marlin stuff. But today we're going to do kind of a like, hey, I've never done this. Where do I start? So I'm assuming you've installed VS Code. Chris Riley has a video on that. Um, and then from there, we're going to figure out what you need to know to set up your Marlin instance. And today we're just going to stick with the configuration.h file. Tomorrow I'll do one on the configuration ADV, and then I'm going to do some videos breaking down things into smaller little sections. So don't be afraid to ask questions. I won't backtrack too much, so don't ask me like if I've already gone past where you've joined in this conversation, just let me know. Like I'll let you know, hey, just start over from the beginning. So let's kind of get started here. Let's move Kermit out of here. I just finished printing him this morning, so it's kind of the new cool thing to have on the show. So let me move this over. Let me get chat bring up. um, Gray Bear. Let's see here. Josh is like, why is VS Code better than Arduino IDE? For a lot of reasons. One, Arduino IDE can't do what we need it to do for Marlin 2.0, so that makes it kind of awesome. Because so VS Code that we're going to use, which is a free software, focuses on using platform I/O to compile and do everything, and it's kind of neat. But before we even get into the software, this is the most important part. This is what makes Marlin a lot easier to do, is when you're not just kind of going back and forth, back and forth. So you need to make decisions. So most people don't have a setup like this, but you have to make a decision. So when you're putting your printer together, whether it be a stock printer or you're adding a new board or the print, or you're just like, I'm just going to throw this whole new fancy board in there. So like if you have an MKS Gen L version 1.0, that matters. You need to know what you're starting with, or mini Rambo board from Ultimachine, or what else do I got in here? I got all kinds of. Here's a mini E3 from Big Tree Tech. So you need to make your choice. You need to know what board you're working with, because if you don't know what board you're working with, this makes it a lot more difficult. So one of my favorite boards, and one that's easy for me to understand, so that way I don't lose my place too often, is the SKR 1.4. It's kind of the big popular board, but just make sure you know your board. So like if you're working on a CR10, or Ender 3, they all got these Melzi boards. So it's pretty easy. So you need to know what board you have. Step one, pick your board that you're going to be working with. Either ask someone online, like, hey, what does my Ender 3 have? What does my Chiron have? What does my Prusa Mark III have? Just what board are you going to work with? And the board limits you on what you can and can't do, because certain Marlin features take up a lot of memory. So like on a Melzi board, like it's on a CR10 and an Ender and so on, has a very limited amount of space you can put stuff on. So certain features we're going to talk about won't fit. And this is one of those things that really gets people on a loop. They'll be like, I want to add all these features. How come it won't work? Well, there's not enough room. So you usually have to take away something to put something in, and there's some things you can't really take away. So since we're sticking with the SKR board on this conversation, we won't have to, we won't be limited by anything. There's more than enough room to enable every Marlin feature and have room left over. So yeah, that's your step one. Figure out your board. You also have to figure out what drivers you're working with. So again, you might not have a box of drivers, but you should know what drivers you have. So like those Melzi boards that are in your Creality printer, typically they don't have removable drivers. They're built right into the board, but they have these little A99 whatever chips. You know, a lot of guys are using 2208s, so these are some actual water cut 2208s, and here's some 5160s. So you have to know what stepper driver you're working with, because again, this limits you. So if you're using one of these older chips on your motherboard, you're never going to get things like sensorless homing. So these are features that won't matter to you because this chip can't do it. Now, if you have a 2209 or a 5160 or whatever, you can run sensorless homing because those chips are a 2130 or a 5161. They all have sensorless homing built in. So these are features you can't use if you don't have the right chip. You might have sensorless homing on your chip, but you may not want to use it. So again, first your board, then your stepper, and then we can talk about features. Once we get beyond that, you probably have a screen on your printer. So again, hardware matters. Hardware matters. So you know, there's screens, and Marlin can use almost any screen. So here's a Rep Discount 2004. This is what your Prusa uses. This is what most printers have. It's a 20 character by 4 character. That's why they call it a 2004, because it's 20 by 04 lines. So 20 and 4. So there's your 2004. If you have a Ender, you've got, I don't think I have one in here. You have a 12864. What else do I got in here? Do I have anything cool? I do have one cool screen in here. Let me see if I can dig it out. Here's one of those Vicky 2 screens. So it's a RGB enabled, fancier 2004 screen. So you have to know what hardware you have. So board, drivers, screen. First 3 things you want to understand on your system. So again, write that stuff down. This will help you out when you're working on your printer, because if you don't know what you have, it's really hard to set up Marlin. Like, you're just going to start guessing, because we're doing this from scratch. We're not going to use one of the pre-configured things and all that fun stuff. There's other options too. Do you have a battery backup? So this is one of those large capacitor setups that are a battery backup. Are you going to add one? This matters. If you don't have one, we're not going to enable that feature. Are you going to have a Wi-Fi module? Because you can add Wi-Fi on some of these boards. So are you going to add that? That changes everything. Are you going to have a fancy filament sensor? Are you going to add NeoPixels? Well, we're going to add all of it. We're going to add as many things as we can. We won't add the Wi-Fi. I already made a video on the Wi-Fi adapter. They're basically useless right now until the firmware gets a little bit better. So ignore that there are Wi-Fi modules that you can add onto your printer. They're very slow. Some are better than others, but the ones that I have here are very slow. We will add a battery backup to ours. I have not used this one yet. I usually use the one that's built into the Prusa system. They don't work that well in Marlin because once you power all these nano lights and everything, there's not enough juice left. But we will add NeoPixels, and I'll probably do a dedicated video on this, but we'll definitely hit NeoPixels pretty hard because people really love adding those colorful lights that you see under it. We will have a filament sensor, and other than that, that's what you need to know. You need to start at step 1. Again, like, this is one of the things I see. The most common complaint that I see, or issue that I see, is people don't know what they have, so they don't know what to enable in Marlin. Marlin is very simple. It's just like, which one of these do you want to enable? Like, do you want that Vicky screen, or do you want the 2004 screen, or do you want the 12864 graphics screen that's most common in like an Ender 3? It's very simple. It's just like, you just go down the list and just activate the feature you want. The hard part is tuning those things. So we hope, this video is being very, very brief in those sections, and then I'll break down more dedicated stuff. But if you have questions as they pop up, let me know. But remember, your very first steps are figuring out what your components are. Your other steps are, oh, and again, other components. Are we adding a probe? Because if you had a probe, this changes some things. If we're adding, what else can we add? Do I have anything else I can throw in there? If you have mechanical end stops, sensorless homing, again, these are all going to be features that we're going to mess with and stuff like that. The nice thing is there is a section in Marlin that has pre-made, basically, clones of exactly the firmware that you need. So you can start there, but if we're going to start from the beginning, we'll be good. So again, don't forget about your probe. The next step, after you figure out what hardware you're going to need to know what sizes of everything. If you don't know what size your printer is, its actual physical movement space, this is going to make it kind of weird. Because again, like a Prusa is 250 by 210 by 210. My artillery over here is 310 by 310 by 400. So you need to know what working space is. That's a setting they have to change. So yeah, get all of your stuff and write it all out. Write down what boards you have, write down what drivers you have, write down what other components you want to add, and then also write down what your physical print sizes, your print space is. So whether it's an ender, which is like what, 235 by 235 by 235 or something like that. I think it comes as 210 by 210 by 235, but if you remove the clips, you can change your firmware to use the full 235 of the bed and 235 in all directions, something like that. Or maybe it's 250 tall. Same thing on this artillery, I know it's 310 by 310 by 400, 235 by 230 by 250. Thanks, Keith. So again, yeah, you have to know your dimensions. So my audio might get weird for a second. Once you have all that written down, we can now move to Marlin. So don't forget that you really need to take into account what components you have, what features we're going to enable based on all those components, and then also our physical sizes of everything, because that changes what settings we're going to use. And there are example configurations in Marlin. So if you go to marlinfirmware.org, marlinfw.org, everything is there. Like, you'll be able to find the firmware, you'll be able to find the example configs, everything like that. So if you have an Ender and you just want to make a new firmware for it, there's already that kind of fun stuff. So 325, 400, what printer is that? Professor. There's no Professor, and it's Wizard. There you go. Keith's got the link. Let me add that link to the chat here, or to the screen here. Create a banner. Boom. Add banner. So Wanhao D9. Oh, the Wanhao D9. So yeah, every printer's got their dimensions. So it helps. Like, I was kind of messing with my Mini and playing around with the firmware. And it's like 185 by 185, or 180 by 180 by 185. So you need to know that. These are things that you need to know. You also need to know whether it's a Cartesian, so if X moves individually from Y and the Z moves up and down, whether it's like a Ender 5 where the bed goes down and it goes X and Y. These things all matter. But we'll pick something very simple, something that I know, that way make less confusing things. So we'll work with a Prusa style printer. So the Z moves up, the bed stays level, the X and Y move left and right, forward and back. The home position is left and back. So again, you should memorize where your home positions are. It's pretty common on most Cartesian printers that the left and the bed all the way in the back is home. That would be your 0, 0. So again, some printers are different. Anycubic Mega Zero. Ooh, it's a fun printer. So let's move to Marlin now that we've kind of discussed that first step. That, again, I'm going to say it one more time. I would highly recommend writing down what you're going to work with. Like, if you know what your board is and your steppers and stuff, this way, when you go back and you go, why doesn't this work? And you go on Facebook and you post like, hey, this doesn't work. Share us that list of components you have. Trust me, it's so much easier to help you right away if you give us the list of components and you tell us the issue than it is saying, I have this printer and it's not doing what I told it to do. Well, I'll say something and be like, yeah, but I have this in here now. So it just adds to the amount of work you and everyone else has to do to help you, because this isn't easy in the beginning. Like once you do it 150 times and you make enough mistakes, you'll you'll be like me, where you can, um, you might be able to get it compile on the first try. It might not work, but it'll compile. So yeah, never touch a running system. So yeah, again, it's just writing all this stuff down helps you. It helps anyone that's going to help you. And as you change things, you're good to go. Like Paul has steppers that are built in the board, so you just figure out what boards you have. Just Google Melzi, and it'll tell you like I got those A88, 899, 88s or whatever. What's the difference between Marlin and Clipper? So Clipper is its own. Hey, what's up, Sean from Shauna from Slice Engineering. Um, don't forget that Saturday is VERF, sponsored and brought to you by the humans at Slice Engineering. Clipper is its own operating system, but it's built on running, or not operating, its own firmware, but it runs all its kinematics and such are run off a Raspberry Pi, which is much more powerful. So this is a 64-bit processor with multi-core and a real MCU and all that stuff. So this is what's running your kinematics. So you put Octoprint on here, you put your Clipper on here, you put Clipper firmware on your printer, and this controls all of that. So basically all the curves and movements and stuff are all calculated ahead of time in here, and then the movements are just sent to the printer. So the printer actually can run more efficiently because something is handling all of the hard work before it's sent to the printer. And the printer, you can make an 8-bit processor board like a Melzi work way better. You're no longer limited by the space. You can, whatever you can put on here, you can make run on Clipper. Marlin is meant to go on the board. So if you've got a Melzi or you got a Prusa or you got an Ender, Creality, whatever, they're all running Marlin. Everything is basically running Marlin. The only thing that is mainstream that's not running Marlin would be something like a Duet, which is running RepRat firmware. So there's other firmwares, but if you have any Duet board, it's running RepRat firmware. If you're running anything else, it's most likely running Marlin or can run Marlin. So and eventually the Duet boards can run Marlin because they're working on that. So kind of neat. Is there any benefit to adding? There's always a benefit in using Clipper just because the MCU is much more powerful. The processing power in this is more powerful, and the way it works is better. So it's doing all of the calculations on chip, sending them as needed to the board. So there should never be what's called a buffer overrun, where there's too many processes being sent to the board, and then it gets filled up, and then the thing can't send, and you get what's like a stutter. You'll see the printer just kind of slow down, or if it does a curve, you see it kind of go choppy. That usually just means it sent too many things, and the well is too full. So things are coming out, and it's like, hold on, I got to catch up. And it starts getting choppy. You won't see those slowdowns with a 32-bit board. So if you go to an SKR, 1.3 or 1.4 or the E3 Mini or the rearm board or whatever, what's a Viking? You won't get those slowdowns. You can still overfill the well, but it's not as easy to accomplish. So regardless of money, I choose Marlin just because it makes more sense. I delve into RepRat firmware with the Duet boards, and while it's awesome, it's also much more complicated. Going from nothing to Duet, like I didn't know anything about firmware, and I went to Duet. I was completely confused throughout the time, and I spent most of my time asking people how to do stuff. When I went to Marlin, I was still asking people what to do, but there was much more information. Like I can go and look at a Chris Riley video and I can learn it, and then I can go do it. There isn't a Chris Riley of Duet. So there isn't a resource that I can just go on YouTube and learn from. And that makes it harder. So again, Marlin is very powerful, not just because of the amazing people behind it, but the community that makes videos like this where they explain how to use it. And if there was a Duet of Marlin, or if there was a YouTuber that was like the YouTuber of Marlin for Duet, like that would make Duet much more powerful than it is because it's already a really good platform. So if I had the money, I would put it in Marlin right now because I know how it works. I don't see any issues with it. I don't see any, after running them side by side, I don't see a benefit to RepRap in print quality or the things I do. But if you're running CNC or something like that, where those giant Duet 3 boards are meant to run on, yeah, I would probably go Duet. Hit the like button. Um, what else? Paul, can you put any board in a 3D printer? You should be able to put any board in a 3D printer. It's just space and how you wire it. So going back to the components again, like let's say you have an Ender. There's so many resources to fit a different board in there. There's so many SKR conversions for Ender, SKR conversions for CR10s and stuff like that. If you wanted to put a rearm board in there, there's a little bit less resource, but you can stick. You could still put a broken board in there, but again, you could put any board in there you want. You can replace it with the same board. You can replace it with a worse board. You can be like, there really isn't a worse board than something that is limited in memory space, so you can't actually activate all the features. But going forward, Marlin's pushing towards 32-bit, so you should be focusing on making your printer work with 32-bit. There's no downfall to moving forward. It's not worse. Now, the only things that I would say complicate things is Marlin can break over time. So Marlin being a kind of like the Windows of operating systems for printers, it's trying to work with every single board, every single stepper driver, every single printer, every single component. And new boards and new components are coming out. Like there's new versions of BL Touches coming out. So when that comes out, Marlin has to adapt to how that changes. They added, for us Prusa users, we have the Pinda 2, which has a built-in thermistor in the actual probe. That way it can compensate for things like, because probes that, let me see if I have one in my fancy drawer of random knickknacks. It's a capacitive probe where it measures not by physical touch, but by, so here's a Pinda. You've probably seen like an Ezable, but it's much larger than this. So it has to sense metal. So as it comes to something metal, it strikes, but if it's warmer or cooler, the distance that it measures is actually going to be different. So they added a compensation tool in there. This is actually a Pinda 2, just an original one. So things like that. As new features come out, they have to keep adapting to it. So NeoPixels were something that were new, so they added NeoPixels in there. Power loss detection was something that's newer, so they have to add that. Wi-Fi module, something newer, they had to add that. So when new screens come out or new boards come out, it's always adapting. So that tends to break things. So they'll fix something for something else, and that might break something else. So that's why when I do this, I recommend always using the stable branch and always checking all the forums to make sure it's actually stable. So I've had some that break certain things, like 2.0.5 broke some things, which they fixed in 0.1 variant, and they fixed even more in 0.2. Same thing in, I didn't leave from 2.04.4 because a whole bunch of stuff broke, and then it got fixed, and then I was just like leery of upgrading to 2.0.5, which ended up breaking some things. So again, it's, they just released 2.0.5. I just upgraded everything to 0.2. So good news is that means the video that I'm going to do to show you how to quickly move stuff is going to be a wonderful video. So yeah, we got our bases now. We got our board, we got our driver. So we're gonna say we're gonna build an SKR4 with 2209s. We're gonna run sensorless homing, and we're gonna do all kinds of fun stuff. We're gonna put a filament sensor on there. We'll put a power runout detection on it. We'll put NeoPixels on it. Basically, we're gonna build the printer that I have behind me, running step by step by step. So yeah, let's move to Marlin. And again, if you need the how to install Marlin 2 or how to install VS Code and how to get it working on your computer, go to Chris Riley's videos. He's got that very nice, I don't want to step on anyone's toe because that's already a good video. So watch his video on that, and then you can, learn how to run it. And then once you've got it installed and all the proper packages and everything running, you're here. You're ready to do this stuff. Because I can't uninstall what I have. Well, I can uninstall it. I just don't want to uninstall it. It's already working good. Yeah, I can. It's actually all the hardware parts are in my GitHub. So, boom. Even the firmware for these printers behind me, so you can look at examples and see how the NeoPixels and how to wire everything. Yeah, it's all there. But let's move to VS Code. So VS Code, I made the font pretty big, but the first step is, I guess we need to have a base firmware. You know what? Since they just released a new one, let's do this. Let's just hop over. Let's stop sharing the screen. Let's share a new screen. So share screen, we'll share my entire screen. Allow. And let's go ahead and hop over to marlinfirmware.org and download. And latest release is right here, 2.0.5.3, and we're going to download the zip. And that should have downloaded already. Let's hop over to another window. And this stuff you might not be able to see very well, but, So we'll extract all on this Marlin thing. It's a pretty big file filled with lots and lots of tiny files, so it takes a second. Even though I'm on NVMe RAM and all that other stuff. But I don't know why I tried to do it twice. Let's go set something up while that's going on. So Marlin builds, my printers, and we'll make a new firmware. We'll upgrade, what printer am I not using right now? You know what, we'll upgrade Slimer. So the green printer right there, we'll upgrade him to 2.0.5.3. And I highly recommend this when you do a firmware, make a new version of it. So don't overwrite your old firmware, because that's just a silly thing to do. Oop, cancel. What? Oh, I already had that folder in there, so it's yelling at me. Let's actually quit that. Downloads. Where's this other Marlin folder at? Let's delete this. That way it doesn't make a confusion. And extract all. That way it's a fresh folder. Yep, so here's our new folder. We'll wait for that to finish extracting. Empty our recycle bin there. I'm going to take a drink of water. And I can't see the chat at the moment because I'm doing this nonsense. I'll hop back and chat in a second. But we downloaded the very first version, or the very newest version of Marlin. So here it is. I'm going to copy that. Right-click, copy, go to my Marlin builds folder, go to my printers, Slimer, and paste it in here. Boom. Now we have the latest version of Marlin stored in. Super easy. Let's hop back over here. Go back to StreamYard. Stop that share screen. 2.0 does work on 8-bit. And let's go back to sharing our screen. Now I can see the chat. Let's go to Marlin VS Code. Okay, we're back to VS Code. It's full screen. Cool. Let's go to File, and let's open that folder. So how I do it is a little bit different than Chris Riley. He opens up a new project here. I go to File, Open Folder. I learned this from Keith. And so we'll go to My Printers, Slimer 2.0.5.3, and we select the folder where everything is. If I click here, this is where all the important info is. We want this folder. So select that folder. and it'll take a second to load. And once it all loads and it's all good, extensions have been modified. Reload window. Look at that. We just had an update. Okay. And the first thing we need to do is go back down our list. So the board. The board is the key feature here that we need to worry about when we work with Platform IO. So we're going to start with platform io.ini. And this file looks confusing. You're like, what in the world is this? Well, simply put, this is the environment chooser. So when you build, when you hit this little check mark button at the bottom of the screen to build the firmware, it needs to know what processor you're building it for. So here's this default environments, and it's set for Mega 2560. So if you're doing like a INC Rambo or a mini Rambo or a any Arduino based board, it's a Mega 2560 most likely. So you basically need to know what processor it's running. Believe me when I say the processor that's in a SKR 1.3 or 1.4 is an LPC 1768. So if we scroll down, eventually we'll find one that says like LPC environment LPC 1768, like right here. That's the environment we need to use when we're doing everything. So the first thing you should do is, again, look at your component list, grab your board list, and be like, what processors are in here? LPC 1768. That's all we have to do there. Done. Now let's go to Marlin, and let's go to the configuration.h. And this is where we're going to do nearly everything for today's video. Tomorrow we'll mess with configuration adv.h, but today we're just going to work with configuration.h. So things like the NeoPixels, the things like the screen, the board, whether you have your filament runout sensor or not, that is all going to be right here. So it's all going to be in configuration.h. The other things that we're going to go and talk about will be in the adv.h, but that's going to be a long video if we did both. So we're just going to stick with configuration.h today. Remember that we're going to use the SKR 1.4. Remember that we're going to use 2209s, and we're going to use a PID V2 and all that fun stuff. So let's go on. Here's some basic information. Scroll down. It tells you what configuration H version, which is 2.5. Define string configuration h.author. So this is where you plug in who is working on it and what the default configuration is about. So I'll type in my name as the name of the person who made this firmware. You don't have to do this. You can leave it blank, never change it, but it makes sense. And then default configuration, I like to use that section for what's on my printer. So SKR 1.4 slash 2209 slash Pinda slash, is there anything else we're adding on here? With Power Panic, so PP. So this is a 1.4 with a 2209 with a Pinda with PP. That way I can look at it real quick and know what's on this setup. Show the boot screen. It'll just say Marlin and the firmware variant that it's at. You can leave that on or off. How do I turn things on? How do I turn things off? To turn it off, very simple. And nice thing about VS Code is VS Code highlights things that are actually activated. So this define string, anything that's this dark green color is not actually read by firmware. Nothing is happening here. Things that are highlighted in a different color tend to be something that's activated. So watch this. If I actually put 2 backslashes behind it, the define runs away. The whole thing turns green. So, and if I remove those 2 lines, it becomes activated. This is the coolest part in VS Code. This is what makes it kind of easy. It's like, oh, did I activate that? Did I deactivate that? Real simple. Did it change color? Is it now pink and blue versus green? Boom. So yeah, syntax highlighting is your friend right now. Define show custom boot screen. Depends on the screen. We're going to use a 2004, so rep discount 2004 screen. You cannot use a custom boot screen for that because it's not a graphical display. So we'll leave that blank. Custom status screen, leave that blank. Serial ports. So this is going to be different on every board. I'll go into more detail at a different time. Basically, your boards all have different serial ports, whether it's the USB port or a TFT port, everything like that. So, you know, it is going to be very dependent, and this is where, remember when I said that there are Marlin configs already done for you for most boards? That's where this comes in handy. It's really hard for me to tell you what your board needs. Just know that every board is different and that you want to use the default configurations that Marlin has made if you have a known board so you can look at it. But for the SKR, I need to enable both port 0 and port -1, where port 0, I believe, is the first serial port and the -1 is the USB serial port. So I need them both enabled in order to use those correctly. The next thing that you want to do is worry about what your baud rate's going to be. And this depends on things. So a safe baud rate is 11.5/200. Everything should work at 11.5/200. It's slower, but most things should work at any of these baud rates. 250,000 is fine. If you have a Melzi, I would probably lower that baud rate. But for this board, I can run it at this. But because we might add things in later, and we'll talk about those when we get there, I'm going to choose 11.5/200, and I'm going to put 2 backslashes and write that the stock value was 250,000. So if you do things like a touchscreen or something, these things matter, but for now, just know that 11.5/200 is a very safe baud rate to work with. It's not going to be too slow. It's not going to cause issues. The SKR14 will work at 250,000, and just remember, you can do these fancy things right here and be like, that's what the value used to be. Do we have Bluetooth? No, we don't. Motherboard. Remember when I said we know what board we have? Oh man. So, define motherboard, and this is already set for board ramps 14 EFB. We don't have that board. We have an SKR. So what we do is we right click and go to definition, and here's the board definition. So it automatically shot me to exactly where it needed to go, which is boards.h. And we keep scrolling until we find our SKR 1.4 board. So here's your Melzi Creality. Everything all good to go. So all these boards are in here. And here we are. So here's LPC 1768 ARM Cortex. We actually have the turbo on that machine. So let's scroll down to the turbo, which we'll have to change something. And then we can go back to our Marlin configuration.h. And we can just highlight this and paste that the motherboard is board BTT SKR version 1.4 turbo. Let me go change some things. I just realized that printer has a turbo board. So SKR, and I'm going to write turbo in here. And we'll have to go back here. The turbo is a different chip, LPC 1769. It's just a different processor. It runs at 120 megahertz versus 100. Everything else stays the same. So if you didn't have that, you would just remove the word turbo from it. Do we want a custom screen name? Yes. We're going to call this printer Slimer. And you can call this thing any you want. Now remember, the length of your screen determines whether or not you can fit all the text on the screen. So you can write a whole one like, you can write purple monkey chunky, and it might not fit. You might you might see your screen scrolling. So I tend to pick a shorter name. It's not that hard to change. Next is kind of neat. So printer's unique ID, and if you have, this is very situational. It's not actually not that situational. If you have something like the MKS Gen L board, this is one of the issues with the MKS Gen L board. I don't want to get too technical, but basically their identifiers on the USB port are all zeros. So it's if you have 10 machines running the same brand MKS Gen L, if you try to log in via Octoprint or Repetier or anything like that, they're all going to have the exact same name. It's just going to say USB 2.0 dash underscore a bunch of variables, typically all zeros. You can add a custom machine UID. That way you can kind of like find that. Chris, I should put some Alien 3D parts on there. But if you have that issue, like they're all coming up the same and you can't find that, follow this link right here, this UUID generator, and it'll generate a unique ID for all your printers. And you can plug that in here. So you'd basically just undefine it, or define it, sorry. You define it, and then you'd change this variable here. Yeah, and that'll give each one a unique identifier. Kind of cool. How many extruders does my printer have? One. You have to have at least one. It's really hard to have a printer without an extruder. The next thing that we have to do is what filament diameter. I am not sure why. I'm not sure why Marlin defaults to 3.0 filament, but we use a 1.75 millimeter filament. This is something a lot of people miss. Make sure that you change it to 1.75. Don't have a Cyclops. Don't have a single nozzle multiplexer. We don't have a multi-material unit attached. You can define the Prusa MMU2 if you want. It's right here. Line 180, you can just uncomment this and you've got a Prusa MMU attached to your thing. Don't worry about that. We don't have parking extruders. We don't have a magnetic parking extruder. We don't have any tool heads. So a lot of this stuff is just silly. Keep going. We don't have a PSU that we can control from firmware. And the next important setting, thermal settings. Let's see what Sheriff said. Oh yeah, I have this enabled in SKR, but not SKR. Oh, I'm going to manage both. The SKR has unique USB identifiers for every unit, so there's no issue. I have all of my printers running a different USB, all on the same Pi, and they all come up as a different printer. So this is interesting. So based on what components you use, again, your components matter. If you have an E3D thermistor, or you have a slice thermistor, or you have some generic glass bead thermistor, this is where this list is important. So 5, right here, 5, is the typical thermistor value that we'd use for an E3D V6 style thermistor. The little copper with the little thing in there. And this list, unfortunately, is not easy to work with. Knowing what your thermistor is isn't like the list doesn't make sense. Like I wish this said like 5, 100,000 K thermistor, and then it said like E3D. Like that's the typical, and then they've got the other ones that are the PT 1000s. They're down here. These guys, the ones that are the other ones. If we look for a slice thermistor, that is, I think, in the 60s here. Yeah, there it is, number 67. So here's the slice thermistor. You would use code 67. So just know that if you have an E3D style, you would use 5. If you have a Creality machine, it's most likely number 1. Our bed thermistor on our Prusas is a number 1. So 5 and 1. So 5 is our hot end. 1 is going to be our bed. If you have if you have a Creality product, it's most likely 1 on both bed and hot end. This is where it gets a little. This is, I think, the most complicated part in Marlin is knowing what thermistor you need. Unless it's something like the Dies Design 1 or the Slice Engineering thermistor, because it actually spells out this is the Slice Engineering thermistor. So yeah. So scroll down a little bit, and here's our sensors. And you're going to be like, why is there so many sensors? Well, the good news is we only need one sensor for, well, we need 3 sensors. We need 1 for the nozzle, we need 1 for the bed, and as you can see, there's a section here for the probe, which is our PID 2. Our temp sensor for our 0, which again, 0 just means E0 is the first tool. I don't know why it's not E1, but E0 is tool head 1. and E1 would be tool head 2, and so on and so forth. So temp sensor 0 would be for our first extruder, so that's a 5. So that just says that my hot end has a thermistor value number 5, and I'll use the temp table stored for that, so that way you get correct temperature readings. You can leave everything else blank because 0, if we go back on our list, it says not used, so it just will not compile. You will have no issue with leaving all these 0. You can uncomment them out if you want, but you don't have to. It won't be part of it. Oh, binary starts out. Screen out of focus. Oh, you're out of focus. Temp bed sensor. That is a 1 for Prusa land, and the sensor on the probe. And again, you wouldn't. Yeah, it's only 720p through StreamYard. I can try making it larger. View, appearance, zoom in. Does that help any? I made it bigger. So down to, it's down to 480. That's crazy. Well, I made it bigger. That should help a little bit. Now it looks great for me. I can stand back. No. So again, this is where it's not listed again. You won't know this unless I'm telling you. Temp sensor on the probe is also a 1. So both the Prusa's bed and the Pinda probe that I showed you early, Pinda version 2 specifically, the 4-wire one, has a probe in it, and it is also a 100,000 value. You don't need any of these dummy values. You don't need any of this, but we do need this temp residency time and bed residency time. Basically, what this does is, let me stretch out the screen a little bit. Maybe we can see a little bit more. There we go. This tells us how long to wait until it's settled. So the longer you wait, the more stable it should be once you start printing or something like that. It's not a big deal. You could lower this value where it's how many seconds of time to wait. So basically, let's say we set the nozzle to 190 degrees. Your printer won't do anything until it's at 190 degrees for the 10 seconds, or the bed is at temperature for 10 seconds. If you lower this, it's fine. So something that's actually very safe to do, and what I've been doing lately is setting these at 2 on both the bed and whatever. And all that says is, as long as it hits the correct temperature and then it's at that correct temperature for at least 2 seconds, it'll begin the next move, which is, when you're doing a heating cycle. So when you're telling the printer to, like, let's say print. So let's say it has to get to 210 at the nozzle and 65 at the bed. As long as the nozzle hits the proper temperature for at least 2 seconds and the bed hits for at least 2 seconds, it'll begin to print. It won't sit there. 10 seconds is a very long time to wait. I noticed that helped a lot. Temp window. This is your proximity for the reach timer. I tend to increase this a little bit just to be safe. And then considered close enough to the target. This last one here, the temp hysteresis. Hysteresis. This is kind of one of the things that happens when, let's say, you're printing and you're like, oh man, it only dropped a few degrees and I got thermal runaway. So thermal runaway is an amazing thing. It saves us from having a lot of fires. So when most issues happen is the temp drops and it doesn't increase fast enough and the printer kicks in an error. And right now its proximity is 3 degrees. So as long as it gets within 3 degrees in that time frame, it's okay. If you don't get within that 3 degree window within the amount of time, yeah, it starts to throw errors at you. And you can increase this. I wouldn't increase it past like a 5, 6, 7, or 8. We're going to go with 5. So it's just close enough for the target temp. So like, let's say you're printing and after the first layer, the fan kicks in. Your fan could kick it down like 8 degrees. And if it doesn't get within 3 degrees within the amount of time that the watchdog / thermal runaway, all that safety protection stuff happens, you're going to have an error. It's going to say thermal protection error, shut down, and your print's done because the fan was too powerful. So if you have like a cheap fan, not a big issue. But when you're like me who puts on a big beefy, 8,000 RPM fan, I get false positives basically. So this is where you start fixing the first step in fixing false positives. And there's, yeah, and Keith does say there's another section in configuration advanced.h. These matter as well. I've had to do both in some areas to get things to work correctly. But we're gonna go back to 3 and 3 here. These are all good. These are all good. You can tell you have a PINDA or PINDA 2 if you have 3 wires or 4 wires in your PINDA. 4 wires has the thermistor. It's a white. Is it the white? Yeah, it's the white cable is a thermistor on the actual PINDA. So our next section is how low do we want to allow our printer to get before you get a min temp error. I run my printers in a very cold basement. Typically it gets to about 15 C in the middle of the night in the winter. So on my normal Prusas, I'd get an error. I'd wake up and it says min temp. You're like, why do I have a min temp? My printer's been off. Well, that just means you hit Marlin's suggested minimal temp before working correctly. And there's a reason for this. High temp thermistors don't work accurately at low temp. So if it's reading something like a 5 or a 4 degree or a 10 degree, this could cause an issue. Now, thankfully, most modern thermistors don't have an issue reading 5 degrees, 10 degrees Celsius. They won't be accurate within 1 or 2 degrees, but it's close enough. So leaving these at 5 is fine. But if you have a thermistor, you can raise these for if you can. So like, I know my basement doesn't get below 10 C. I can leave this at 10 C for the bed and the hot end. And there shouldn't be a problem. I won't wake up in the morning with a min temp error. But 5s are safe. Just do not set these. Do not turn these off. Because you need to have this is a safety feature. Don't fudge with it. Max heating temp. Now this depends on your printer. So like, let's say we have an Ender or a Creality printer with a Bowden setup where the Bowden tube goes all the way into the nozzle. You have a safe printing temp of no higher than really 250, 255. You can kind of do 260. If you swap it out for like Capricorn tubing, you can get up to a little bit higher. The marketing hype on Capricorn is a little bit suspect because it's still off gassing. So if you don't, again, this is the basics. So again, if you have a Creality printer, the reason why they firmware limit the max temp is because that little plastic tube, that PTFE tube, off gases a neurotoxin once it reaches a certain temperature. So if you print at that temperature or above, you begin to release a neurotoxin, which won't kill you, but over time can cause issues. And it'll also start to degrade the PTFE tube. It has a maximum working temperature. So the misconception with Capricorn tubing is it says it can print up to 300 degrees Celsius on some of the higher end Capricorn tubing. Yes, it just means it won't degrade, but it's still off-gassing those neurotoxins. So you still should not be printing with Capricorn tubing at 280, 290 degrees Celsius. This is why people switch to an all-metal hot end, because an all-metal hot end is only limited by the max temperature the actual metal material can last. On a stock E3D V6 with an aluminum heat block, your max actual printing temperature is just below 280 degrees Celsius. And that's another marketing issue is they'll say E3D V6 capable of printing up to 450 C, asterisks only if you have the titanium heat break and the copper block and a copper nozzle. The brass nozzle isn't good past 300 C. The aluminum block doesn't actually begins to expand after 280 degrees C, so you begins to loosen, so your nozzle can actually fall out mid-print. And the stainless steel isn't good past like 350 C. So there's a big asterisk there. 300 C is typically safe, like if you're going to do nozzle changes and stuff. So typically we say 295 when we have an E3D V6, only because we need to get to that safety buffer. There's like a 15-degree buffer. So our max heater temp is, if we want to get to 280C, we need to say 295. You can also do things like 295 plus 15. And that will just say, that's just a buffer. So we'll just write the 15-degree max buffer thing. Same thing with the bed. On the bed, a Prusa bed can only get to 120 plus the 15 buffer. So yeah, you can do math in there. Yeah, the buffer is 15, Mr. Jordan. So again, this is how you would do it. Oh, 10 on the bed. Okay. Plus 10 on the bed for the buffer. I actually haven't done these in my firmware because, again, there's no material that prints at 295 that you really need to use. I mean, I guess if you're printing like super crazy nylon with a lot of CF and you have a hardened nozzle and it's layers are separating, you might need to push it all the way to the 295 to get it to print. But your PETG, your ABS, most nylons, most polycarbonates will print below that buffer, and they should work just fine on a stock E3DV6. The only time we need to worry about adding a titanium heat break and a copper block and a copper nozzle is if we are printing Peak or Ultim or Thermax, these materials that print at above 300 degrees Celsius. So your Creality machines, your TiVo Tornadoes, your artillery sidewinder, your ANETs, 250 to 260 max. Your things with an E3DV6 or an all-metal style hot end, so if you upgrade your Creality to have the Micro Swiss hot end, 295. The bed is dependent on a lot of features. There's very few beds that are rated above 120C minus those E3D like high temp beds. There isn't a material besides, again, like Peak and Ultim that you need a hotter bed, but you also need an enclosure that can retain that heat. Don't take an ANET above 220. Yeah. We don't want to be too mean, but yeah, this is, again, printer dependent. Your hardware very much so defines what these values are going to be. And that's why it's really good to look at those example configs from Marlin. So let's scroll down. Now that we've kind of hit that area, let's talk about the PID settings. So what PID settings is, it's something that you should do, like one of the first thing you do after checking whether your printer moves and homes and works correctly is to PID tune, or basically tune the heating cycling. So when you first run, if you turn this like define PID temp and all this stuff off, all that means is you're going to use what's called bang bang, which means it's just going to turn the heater on until it reaches temp and goes past a few degrees. Then it turns off the heater. Then once the thermistor reads that the temperature has dropped a few degrees below, it turns the heater back on, which leaves artifacting on your prints. Because as the nozzle and bed are both heating in cycles and not evenly heating it in a consistent manner, you're going to get thinner and thicker lines. It's a very common issue that you'll see on your prints. You'll be like, why is my printer having these thin and thick lines? 99.9% of the time, well, okay, I'd say about 85% of the time, it's your PID tune. Either you've never tuned it, or the manufacturer never set a good PID, so it's just jumping really high to really low and just going on off. So we want to have our PID tune. I also like to enable the auto tune menu. So this allows you to tune your PID settings directly from the calibration menu. So this is all there, or in the temperature menu. Here's an interesting decision. We won't edit this today. We'll get back to this on a different day. But this is if you want to define your own values here. And there are known values for most beds and heaters. Like here's, some that are already here. If you go to those, again, those pre-made values, the pre-built configs from Marlin, you'll have values here for your ender bed, your artillery bed, and so on. We're going to leave these blank. We can set these manually, and I'll show you how to do that later. The next option is PID heating your bed. And yes, you should do this, because if you don't, again, it's just going to use bang bang, which means if you set your bed for 60, it's going to go to 65 and then go down to 55, then turn the heater back on, go up to 65, and go back down, and it's just going to make these cycles. You're going to get some interesting print stuff. Scroll down, scroll down. This is a section that really depends, again, whether you have a Bowden setup. Well, this section right here depends if you have a Bowden or a direct extruder. But this cold extrusion temp, your minimum extrusion temperature, I set this to 180 myself. 170, I've had materials that will not extrude at 170. 180 is far safer. You can leave it at 170. All it's telling you is, like, let's say you want to load your printer up and you're going to hit the actual load button. 170 is a pretty low temperature. Some PLA will not extrude at 170. Most of them will. There's just a few that I've done, like the matte fiber stuff where it says it can print down to its typical min temperature, like 190 sometimes. 180 is good. That's just that's a me thing. You can disable this if you want, so that way you can always extrude, but then you have the issue of, oh my God, I forgot to turn on my heater, and now I hit the load button, and now it's grinding my filament because it's doing that. Now, you want something here, and 170 is great. I go to 180 because I have materials that specifically just, they will not extrude at 170. They'll go fine at 180. And then your max length. And again, this matters. So let's say you have a large Bowden and you're going to use the loading feature. Well, this 200 millimeters of maximum extrude in one segment is going to limit you, because if we have like a CR10, our Bowden length is much longer than 200 millimeters. So in order to be able to load our filament into the hot end, that needs to be higher. And I think on a lot of them, it's up to 500, 800 on those. So this matters here. So if you're having issues when you're configuring an auto load feature, which we will set up here tomorrow, that's in the configuration advanced, we will not change this for our printers, but if you have a printer that has a Bowden tube, so an Ender, a Prusa Mini, which you can't change the firmware on anyway, or a CR10 or a Chiron, no, that one won't. But yeah, you would edit your max length that you can extrude, because your extruder actual gear is further away from the actual hot end, so we need a longer length. For us, we don't need that. Thermal protection, never touch these. Just do not leave these all these on. Don't disable chamber, don't disable it. You don't have to do any of that. Here's if you have a Core XY machine, we don't have that. We don't need to worry about any of these plugs or end stop pull-ups because we're using sensorless homing. We don't have to worry about end stop inverting because we're using something with UART. What's up, Mr. Buttram? So end stop inverting is typically done if you have like an SPI, so a 2130 or a 5160. You'll change the min end stop inverting from false to true. Remember our fancy list? Here's a list of all the different drivers. So the Melzi board A4988s, but we're going to use the TMC 2209s. We're specifically going to use those 2209s in what's called UART mode, which basically is a two-way serial bus. So the chip can talk to the board and the board can talk to the chip. Standalone, which is very common, just means you're sticking the driver in and it's just going to work. This is just a dummy. It's just, there's no talking. You can't, you set the VREF directly on the chip. You do all that fancy stuff. We don't want that. We want these TMC 2209s. So all I did was copy that. We have an X driver. We have a Y driver. We have a Z driver. And on this printer, we have a Z2 and an E0. Whew. And your printers are all going to be different. So let's say you had a Prusa with a Einstein Rambo. It only has 4 drivers. So it has one for X, one for Y, one for Z, but it's split in parallel, and then an extruder. So you cannot do this. You'd be like, oh, I get one Z. If you have a MKS Gen L, you get one Z. If you have a Melzi board, you have one Z. We have an SKR. We can make multiple Zs, and there's a reason. I know that the SKR has a Z that doubles them up. It runs them in parallel, so you can run 2 Z on one stepper. But there's cool features that we're going to add that involve having both Z axes enabled. And what we're going to do is we're going to add a 5th stepper to our E1 port. So we don't define E1, we just define our Z2. So don't go defining E1 thinking you're going to get Z and E1, and no, it's two Z's. You define, Marlin's smart enough to know that when you do X, Y, Z, enable a Z2, you're good to go. And then, of course, our one extruder driver, so E0. Here's a neat feature. Let's say we're going to use physical end stops. You need to enable end stop noise threshold. Basically, they'll falsely trigger due to the fact that there is some noise and stuff like that going on. So you would fix a threshold. My yellow printer back here has physical end stop, so I would define that. We're not going to. Movement settings. I'm going to briefly go over movement settings. Let me swap back to me on camera, and we're going to go over the movement stuff. So don't forget to change your driver type. Didn't I change my driver type? Oh, I didn't change my driver type. We'll go back to that in a second. Let's do this one. Okay, and I'll change my driver type. So basically the TMC229 goes into each slot. Thanks, Keith. And then we'll scroll down here to these settings. These are the ones that confuse most people that I see. So they'll be like, hey, Chris, how did you get 100? How did you get 200? How did you get 80? How did you get any of the settings that you have? That's a really good question. So there's different types of motors. Here's a 1.8 degree motor. Let me remove this banner here. Banner. Here's a 1.8 degree motor. Here's a 0.9 degree motor. Here's a 3.7 to 1 geared 1.8 degree motor. Let me grab my box of pulleys. Hopefully I have enough pulleys to show this off. Here's a 16-tooth pulley. And I gotta actually get up and go to another printer to grab a 20-tooth pulley. Because again, components matter. So your two most typical motor, your most typical motor is a 1.8 degree hybrid stepper motor. It has 200 steps per 360 degree rotation. Pretty simple. How do I know this? It's just a fact. 1.8 degrees, if you divide that by 360, is 200. So it moves 1.8 degrees per step. If once you move all 200 steps, you move 360 degrees. A 0.9 is twice the resolution. It moves 0.9 degrees per step, making it a 400 step per 360 degree revolution. Well, that was fun, right? So when we look at this 5mm, again, these are all 5mm rods. That is your base point. So 500 millimeters. Anytime you shrink that, the steps actually, the amount of, don't forget to go back and change the max. No, 295 plus 15 works. You can leave it at 295 plus the number, and Marlin will do it. So Marlin knows it's 310. So you can leave it that. It's kind of neat. You can do math equations. You can do 190 times 2. And that could be your max temp. It's kind of fun. We'll actually use that later in another area. So your most common in the Creality, TiVo, basically every printer that you're used to land that most people have is a 20-tooth idler. So it's just the fatter idler. Every Creality printer, every ANET, everyone uses a 16-tooth or 20-tooth idler. And that goes right there. Or I guess it's a pulley, 20-tooth pulley. So this changes how many steps you get per rotation. Oh no, we want 295 plus 50. We want to be able to get to 295. So it's 295 plus that 15 degree little area. So 295 plus 15. So whatever your max temp you want to get to, plus the 15 degree little like thing. So let me screw this on here. So when we attach our pulley to this, we now have a difference in how much length is moved on the belt. So there's a website for this, but a 1.8 degree motor with a 20 tooth, and we can measure that if we just grab this and we measure the diameter. It should be 20 mil. It should be 12. Yep, so 12 millimeters. So you got one of these fatter ones, and it's 12 millimeters on the teeth, ish. You have an 80 step per millimeter movement. Again, the larger this gets, the less resolution you get. So the steps per millimeter is just resolution. It's how many steps it takes to move a millimeter. It takes 80 steps to move 1 millimeter with this 20 tooth pulley on this 1.8 degree motor. If I move this same pulley to this 0.9 degree, because it has double the resolution, it goes from 80 to 160. Because what is 80 times 2? 160. So that's how you do. I mean, the math is simple, just knowing these numbers. And there's blog. I'll grab that from Keith. Control C, StreamYard, and create a banner. Boom, add banner, show. So if you go there, you can do the math there. You can be like, I have a 1.8 degree motor. I have a 20 tooth pulley. What are my steps per millimeter? Now, these aren't perfectly exact. The motor should be very, very close, plus or minus like quite a little bit. Like it should be very accurate. It's not perfect. These values are very close. And again, if the place you buy, like if you buy these on AliExpress, I can guarantee you that they're not going to be the exact size. You might buy 5 of them, and all of them are going to be slightly different. So your steps per millimeter may need to be edited. This is a base value. If you buy good equipment, if you buy from Moons, if you buy from LDO, if you buy from Steppers Online, you're most likely going to get a very good motor that's going to be moving the correct amount of steps because they're high precision motors. If you buy the E3D or the LDO pulleys, you're going to get high quality, well-made pulleys that should be within a certain tolerance. So that way, when you buy them, you can just plug and play these values in and you'll be very, very close. As long as you're within 1%, you should be very good. So what happens when we add a 16 tooth pulley? Well, interesting number. We go from 80 to 100. So when you have a Prusa printer, which all Prusa printers run a 1.8 degree motor with a 16 tooth pulley on both X and Y axis, you would have a value of 100. If you move that to the 0.9, guess what? 200. So again, your actual physical components tell you what your settings are going to be. Knowing them again is the issue, because they don't spell these things out. If I buy a CR10, it's not going to say I come with 20 tooth pulleys and a 1.8 degree motor. Typically the motor, everything's removed and there's nothing written on it, or it might be stamped. Like this is just a stamped Moons motor, so I can kind of sort of read that it says as not a 0.9 on there somewhere. Yeah. No, it actually doesn't say 0.9 on here anywhere. It just says the model number, which is HA2, which is, since I know this motor company, HA2 just means it's double, so it's 0.9. LDO spells it out a little bit better on their motors, so this one actually will say 1.8, the motor style, and then the model number, and then the amps that it needs, which we'll need later, is also written on here. The amperage you need on this is also written on here, and I'll show you how to do that from that code when we get to figuring out what amps we need for our motors. But yeah, those are your two most common motors. So when you switch to 32-bit, you can throw these 0.9s on. That's really cool. You can actually get higher resolution switching to a higher resolution motor. If you're on an 8-bit board, don't start throwing 0.9 degree motors on your printer for more resolution. This is something that I only recommend for people. NEMA refers to the size. So NEMA 17 is the physical size of the motor. NEMA 23s are bigger. I think it's by centimeters or something like that. I can't remember. So it's NEMA 17. So NEMA 17s, 23s are bigger, and then bigger, and then bigger as the NEMA value goes up. The torque is defined by typically the size of the strata and rotor. So I actually have a motor right here taken apart. This is a pancake NEMA 17. This is your rotor, I believe, and inside here is the stratter where everything kind of goes, and there's all the magnets and coils and whatnot. Again, do not take apart your motor, because as soon as you pull this away from this, you ruin its ability to be magnetized. All motors, hybrid stepper motors, are magnetized when they're fully constructed, not like this. They're not magnetized right now. It's actually lost some of its torque now because I've done that. This is my junky extruder motor that I ripped off. I now have a Hemera on there, so I no longer need this. So I was like, hey, let's take it apart and have it as a show and tell. And those are those steps, so you can see the 200 steps. So when it actually clicks and is locked in place, which I have a really hard time showing on camera, that is locked in place. So again, I wish more companies would label stuff with, like, Steppers Online just puts a model number, and you can discern what the motor is based on the model number and what the specs are. Same with the Moons. Like Moons, I can discern based on reading the. So this says MS17, which is Moon stepper motors. NEMA 17. HA2 means it's double, so it's 0.9, and then 4100 means that it's 4-pole and 1 amp. You just gotta like learn these things when you mess with stuff. So that is your basic motor stuff. We're going to be using a 1.8 degree motor with a 16 tooth pulley. So we need a value of 100. So let's go back. So our steps per axis for X is going to be 100. For Y is going to be 100. And our Z, which again, you'd use that fancy calculator for, would be 400. Or what Prusa used to do on their firmware was 4,000 divided by 100, which is what it actually is, but that's just 400. And then our extruder. Now this is where it gets tricky. Let's go back to me on camera. Right here. How do we figure out our extruder E-steps? That's a fun one. It all has to go back to the motor degree, what degree motor it is, how many micro steps it is. So this is a 200 step motor. Not micro steps, how many physical steps it is. And then also what size thing on there. Let me see if I can find, I have a Bondtech gear around here somewhere. Bondtech gear. I probably don't have one nearby, but I know where I can grab a whole bunch of things right here. Because I always have motors with stuff on it. So this is your typical, let me spin it this way so that way it focuses. These are your typical hob gears on an old like Mark II printer. And again, these are all going to be different on every printer you own. Where's my tiny one? There it is. Because again, math is all based on the size of things. So if I attach this teeny tiny hob on here, this is called a hobbed gear. So quick reference question to the chat. Which one of these has more steps? Which one has more resolution than the other? Is it going to be the one with the 16 tooth pulley or the one with this tiny, I think it's 5 millimeter? Not 5 millimeter, 8 millimeter? 6.5 millimeter. So Mr. Buttrum's right, the small one. Because again, we learned that 20 is less resolution. This is even more resolution. This is way more resolution. And based on the actual diameter, we can figure out the resolution. I believe it's actually going to be 167 for this. But that's how you'd figure it out. Now, thankfully that there are actual diagrams for this. so you don't have to do math, but that's where those values come from. So if you never knew where those values come from, that's where the values come from. This one's like on a 0.9, so this is 0.9 with this should be about 320 steps. You know, if I buy a Hemera, they've already listed the number of steps. If you buy a Bondtech, it says I'm 415 steps with a 1.8 degree motor with the gears. So it's 400 at what micro stepping you're at. So we're using a base stepping of 16. I forgot to say that. But yeah, that is your lesson for the day. That's where those values come from. I have on that printer this motor with a Bondtech gear attached to it. So this is a 3.7 to 1. So if I bust out my fancy calculator and I do some math here, a stock Bondtech gear is actually 280 steps on a 1.8 degree motor, but I'm going to multiply it by 3.7, so I have 1,036 steps for this 3.7 to 1 gear ratio. Actually, wait. That was something I found. So this actually comes out to more like 3.5 to 1 based on this design. So it's actually 980. So it's 280 times 3.5, which is 980 steps. So that's how I found it. So this is a planetary gear motor that's 3.5 to 1. So whatever the input is multiplied by 3.5. So it's basically this times 3.5. So if this gear is 280, then on here it's 980. So there's your math. So we're going to go back to VS Code, full screen, VS Code, 980. Boom. So 100, 100, 400, 980. Default max feed rates. Yep, these are values that I don't know off the top of my head. We'll go over them later, but this is also defined by your printer. If you have something with a 400 by 400 or 500 by 500 bed, your speed that you can run, the max feed rates are going to be much lower than something that has a 180 millimeter bed because mass. If you go too fast, you'll skip steps. You'll have issues with your prints and artifacting. So these are very much involved on this, and you can mess with these. I usually recommend a smaller value to start with than going forward. We will not add these yet. I'll show you how to add those in on a different day when we use a different program. Max acceleration. This, again, is defined by what kind of printer you have, what motors you have, what kind of torque you're going to put into them. Like, if you run every axis with a pancake motor, one of these really thin, small motors, you can't run them at accelerations very high. So one area that we will change is the default accelerations for printing. I always start with 1250. You should all start at around 1250 for these values. This is a good starting value. If you start noticing issues, decrease. If you think you can go faster, increase those to about 2000. Those are about theoretical limits for things like most Cartesian printers. You can probably push these higher to print much faster, but these are limits where I say you're going to get good print quality and you can override them in your slicer G code if you want to go even faster, but they're there. This is a section that's changed. A lot of us are used to having a jerk value of something like 10 or 20 or 15 or 8. If you have a Prusa, typically your default X and Y is about 8 and your default jerk is 0.3. This has been removed as the default option. We now move to what's called junction deviation, and you can read about junction deviation all you want on these two websites that they have listed right here, and I highly recommend you read them. Basically what junction deviation does, instead of taking a hard corner to make a 90-degree corner, it takes a curve which lowers the jerk factor, and you basically add a deviation from the curve based on these settings. Starting at this value is fine. I have found that 0.2 is my value for these, and I leave my e-jerk at 5. How to get to this value, that's a long and difficult process that I will not bore you with, because I don't know exactly the science behind it. I just know what works for the extruders I've tested. And a value between 4 and 5 have been the most successful. Why? I don't know. I'll get back to that, but this stock value is fine. So S-curve acceleration. So S-curve acceleration, again, has a interesting article on what it does. I highly recommend enabling it on a printer that has a board that can handle it, because it does 0.02. Josh, 0.02, not 0.2, 0.02. S-curve acceleration. So basically what it's doing is, instead of taking acceleration as a linear value where you go from 0 all the way to the max acceleration that you set and then immediately slowing it down to the acceleration or decelerating it, it's taking a more gradual curve. That way you get a smoother motion. And this is all done on the processor live, which is intensive. So you cannot do this very, very effectively on a Melzi. I don't even think you should install it. It probably works, but I wouldn't do it. I would leave S-curve acceleration on for anyone that has a higher end board that has at least 100 megahertz processor. So basically you're going to gain print quality through this. So if you take a curve, or if you have a high jerk value, the motion will actually be smoother. My printers, when I use like Prusa firmware, because it doesn't have S-curve acceleration, it's a much older version of Marlin, the whole printer will shake. When you use S-curve acceleration, because it's a much more fluid motion, you'll get much less artifacting. You'll get less vertical banding. You'll get less ghosting and such, because the accelerations are much smoother and the decelerations are also smoother. So I highly recommend, if you have a board capable, so SKR E3 Mini, any of the 32-bit boards should be able to handle S-curve acceleration perfectly fine without an issue. So this is your two-handed front. Your junction deviation and your S-curve acceleration both improve print quality by offloading some of the kinematics directly to the 32-bit processor to improve basically the tool path. So you have better tool pathing that leads to less artifacting. And these can be edited. You can do like a junction deviation test and stuff like that. But if you can enable S-curve acceleration, that's the one I definitely would do. If you can't do junction deviation, classic jerk works fine, but S-curve acceleration has been my favorite for keeping the print quality a little bit better than a stock printer. This is where it gets a little funky. Technically, I should go one line down and go to this line right here, which is define Z-min probe and what port or what pin it's going to use. So let me describe this. We're going to use a PINDA on this printer. So we're going to use a PINDA version 2, which is a fixed mounted probe, and it's not going to go into the end stop pin. It's going to go, the SKR version 1.4 actually has a dedicated end stop pin. It's pin 0_10. And I typically would do that, but there is a brokenness in Marlin's logic. Marlin always thinks, because again, every board is made like this, every board besides the SKR 1.4 and maybe some others think that you're going to stick the Z-min probe into Z-min pin. So if I were to uncomment this and comment this, there actually is going to be an issue. It's actually going to have two probes battling each other, or two Z-min pins battling each other. This is something that I've learned through testing, and I've had some arguments about trying to how to fix it. Basically, don't do this. Leave it like this, even though we are not going to use the Z-min end stop pin. Leave it like that. For you guys that don't have an SKR 1.4 board, you would use this, because this right here is where 99.95% of your probes are going to be inserted into. It's going to go in the Z-min pin, because your probe replaces your Z-min end stop. It's perfect. It works. You should be using this, but it's kind of broken. If you're going to use an IR sensor to stop, same thing. You would use the Z probe, use a Z-min end stop. Basically, any probe you use use this. I will show you on a later video, or you can watch one of my older videos on the SKR 1.4 board. Just leave this right now. Now, for probes, they've got a bunch of different probe types. So fixed mounted probe is anything that's going to be a PINDA or a easeable or something that's not a BL touch, something that's not nozzle as probe. So if you have a conductive probe and a metal plate, you can use the nozzle as a probe. Don't try this if you don't have it. Again, this is a piezoelectric smart effector. This is something that actually use that. Here's the BL touch. Here's the touch me probe. Here's a solenoid probe. Here's a Z sled probe. So again, bracket pinion probe, Duet smart effector, which I have on another printer. Sensorless homing for probing. There's all these options. I won't go in depth on them. Just know that make sure you know what you have. We have a fixed mounted probe, which is basically anything else that's not listed. So we're not using the nozzle. We're not using a servo. We're not using a BL touch. We're not using a touch me probe. We're not using a solenoid probe. We're not using any of these other options for probing. And we're definitely never going to use sensorless homing to probe. We're going to use a fixed mounted probe, which is anything besides all those other options. So let's scroll down. And we need to define where our probe is in space compared to the nozzle, because Marlin needs to know this. Again, remember that first step? Know your printer's hardware. Do I have a hot end I can just grab and show people? Let me see if I can grab a fully assembled-ish extruder to show people. I should have in one of these boxes. Yep, there we go. It's not fully assembled, but it'll work. Let's go back to camera. Let's go back on camera. Okay, I'm back. Yeah, if you have end stops for other things in a probe on a different pin, that's fine. So here's an extruder. This is a Bondtech extruder for Prusa. It's got a little probe hole. Our probe would go here. And when we're probing, that will stop right before the bed. If you have a mechanical switch, it'll do that. If it's a BL touch, the actual pin will touch. Michael, which one? Prinda? I prefer the BL touch, but I have no qualms on using a Pinda or anything similar. They all work. I'll get into differences on probes later, but for now, we need to know basically where in space compared to where the hot end is. So let me see if I got a hot end I can shove in there. I do. Let's see, and I am attached with a screw. Dun, 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 dun. And I'll stick this hot end in here. Oh, let me pull the PTFE tube out there because this is not set up for this PTFE tube. This should pop it out. That won't pop it out. This will work. Boom. Pull that out. Now the nozzle will fit. So nozzle is home 0. That is our drawing mechanism. So here is a nozzle. That's where 0, 0 is. That's our thing we're printing with. That's the most important thing. But our probe is in space compared to that. So our probe, as you can see, actually very hard to see because it's black. But our probe, let me push that out a little bit more. Maybe we can see the silver. There we go. Our probe is not exactly where the nozzle is. So we're going to tell Marlin that the probe is offset from the nozzle. So set of calipers, and you're just going to measure like, okay, this is 23 point something, and this is in this direction like 5 something. I have it listed somewhere. But you're going to do that, and it depends. So if we're looking in space, this is the nozzle. Our hot end would be here. Oh, our printer would be right here. This is X. This is the Y is here. So this is to the right of the nozzle and behind the nozzle a little bit. So if we go back to our list, we can see that positive is to the right and back is positive. left is negative, and front is negative. So if you had a probe that was to the front and right, your value of front would be negative, your Y value would be negative, and your X value would be positive. If it was left and back, you'd have a negative value and a positive value in your X and Y. Z you add in later. So what we're going to do is there's, again, a list of where this all is. I've got that saved because I'm a fancy person and I save the values of what I need. I can also steal it from another printer so I can look at another project and be like, yeah, okay, you know, that's where that goes, where that goes. But yeah, basically what I'm saying is when you put your probe information in, you need to know where it's at in space. So you'd grab your calipers, you would measure, and then that's where your probe would be. So on a Prusa, your X value is 23 millimeters to the right. And let me look on my list here. It's going to be 5 millimeters back. So those are both positives because right and back are positive values. So now it knows, now Marlin knows in space where your probe is. Min probe edge. So you can leave this 0 so you can go all the way to the edge. I actually like the 10, which it's just kind of a safety thing where basically how far that probe edge is, it basically says, okay, here's my rectangle. Don't go within 10 millimeters of the edge of the rectangle, just as a safety precaution. So I do that. You don't have to. You can. You don't. I recommend 10 or 5, but we'll go with 10. XY probe speed. So this basically says how quickly. I leave 0 for now because you're going to find out your distance yourself, and we'll go through that. Again, this is going to be the most comprehensive Marlin video that I can think of. So when we'll leave the 0 for now, and we'll go back later and add those in. Z probe, XY probe speed, that just says how quickly between each probe point will it go. In millimeters per minute, so millimeters per second, you would divide by 60. So if we did 8,000 divided by 60, and everything's math, so 8,000 divided by 60 is 133 millimeters per second or so. That's fine. You can go on a Prusa style printer with a good setup and go to 10,000, 8,000 is fine. If you're getting skipping or grinding, slow that value down. How quickly does the Z home? This is awesome. I learned this from Keith. You can do math. We do a Z home of times 4. So it's just our homing feed rate times 4. So how fast is it? It's our homing feed rate times 4. And then feed rate for accurate probe is just going to be Z probe fast speed times, or divided by 2. So whatever this value is divided by 2. So this value, which is this, divided by 2. So it's just half the speed. Kind of neat. You can do math anywhere you want in Marlin. Multiple probing. I like to do 3 probes per point. I know that sounds like it's going to be, excuse me, super slow. But we're going to use a cool feature in our Marlin that I love. So this is normally 2. And this is normally, again, I started slipping here. This is what it normally is. Okay. It is also for homing, like, yeah, it's for homing XY. So if you do, no, that's not for homing. This is just your XY probe speed. So when you're probing, this is different. This is faster than our homing speed. Homing is very slow. Clearances. This is something that every probe is slightly different. We don't have anything to deploy, so we can actually set this value pretty low. And I'm actually going to go look this up real quick because I just was able to set up a much faster probing speed. My printers and Slimer, and that value is, actually wait, I think it's actually, no, it isn't that one. Slimer, Marlin, configuration.h. And again, every probe is going to be different. So my PID settings are going to be different than your BL Touch or your clone BL Touch, which is going to be horrible because there's absolutely no deploy, 0. So if you have an Ezable or a Pinda, 0. Those will all work. If you have anything that deploys, you need to leave a value there to deploy. So 0. Your next value, let me go to my stuff just so I can memorize it again. Okay, I have memorized it. I don't have to go back anymore. The clearance between probes. You need some distance. So basically, Luis, mine is 8, but this is all refined. I have firmware that's ready to release. I've refined it even more. But Z clearance between probes. So basically, let me go back to video on me. And right here, and video with me in it, it's right here. So a conductive probe will never touch the bed. It hits the bed and comes back up. So it doesn't need much time to what's called go back to normal state. So normal state is nothing touching and then triggered and then not triggered, triggered, not triggered. Every probe is going to be different. What's nice about the Pinda probe is it has a very small stroke where, yep, and then a little bit higher and it's no longer enabled. Something like the BL Touch is different because the BL Touch, that's your stick that comes out, and then when you probe the bed, the stick goes back in, and then it needs to move up and then deploy again and then probe again. So that distance is like 5 or 6 millimeters. So typically we put like a value of 5 there. So it goes down, comes back up 5, drops the probe, probes again. The probe goes inside, it moves up 5 millimeters, releases the probe. So again, it's slower. A Pinda, an Ezable, any of those capacitive, inductive type probes, you have a very short throw. So something like a piezo switch or something like the smart effector has a very short throw because once it's triggered and once you get the pressure off, it's no longer triggered. So you can use a very short throw. So let's go back to full screen here. My clearance is actually going to be a 1. So a 1 millimeter clearance screen. So it's going to probe, move up 1 millimeter, and then go back down to probe again. This speeds it up a lot. And then our multi-probe is going to be 2 millimeters. So it's going to, when it's done probing, it's going to move up to 2 millimeters, move to the next probe point, and then come back down. So kind of awesome. I don't do any Z after probing. That's just silly. You don't need to move it up afterwards. You can. So let's say when you're done probing, you want to move the nozzle up to 10 millimeters. You can. You can set to that. I just leave it there, and you'll see why I leave it there. Z probe low point. This is how low it'll go below before triggering. -2 is fine. Our offset range is -20 to 20. That's fine. Something you should always add, and you'll only use it like once or twice in your lifetime, is the Z min probe repeatability test. So basically what it does is it'll probe one point and it'll keep probing that one point 10 times. And it'll show you the difference between each value. This will tell you if your probe is working well. So if you're having some issues, you can run the repeatability test and you'll be like, wow, my probe is like 1 millimeter off between probes. It's time to figure out what's wrong. If you're below, as long as you're within 0.02, 0.01 millimeters, as long as you're in that range, your probe is going to be more than accurate enough. Now, probes can be more accurate. Like a BL Touch can go down to 0.001. That's more accurate than you ever need because your layer height is, your first layer height's always like 0.02 millimeters. So you don't need a probe that's more accurate than that. We don't need any of this section for what we're doing. Actually, I've never had to use this section. I've never had to use this section, but they did add something. You can turn the heaters off when probing. This is something that should improve something like a Prusa bed that has both magnets and copper traces in the bed because it acts like an amplifier. So having the heaters on while probing can cause probing accuracy issues. And I believe Prusa is going to add this in their newer firmwares where it disables the heaters during probing. You can do that if you want. I have no issues with probing accuracy. I might test it and see if it helps. But for general people, your probe is going to be more than accurate enough that you do not need to disable this or enable that feature. Do we need this enable pins for inverting stepper pins? No. Do we need any of this stuff? No. Do we need this? No. Stepper directions. Printers are poor. Oh, I didn't know about that. So, invert the stepper direction. So this section right here is one of those sections where it's like my motor's moving the wrong way. How do I fix it? Right here. This printer is, let me double check. And this, you won't know this until you actually start working on it. But this printer is actually true, false, true. And I believe it's actually backwards for the extruder as well. Let me double check my list here. Yes. So, oh no, it is false true. So it is false true. Those are all the same. But this is how you'd flip them. Now I'm flipping them back to the correct direction. My extruder does move backwards normally when plugged in. True. So your motors will change this. I cannot tell you what direction your motors are going to be. You will want to open up those pre-made configs from Marlin, and you'll be able to look at them and be like, okay, this is what it should be. And if they are backwards, because it can happen, you would just go here and flip it. So if your X is moving the wrong way, you would change that to true. If your Y, again. And then the E0 is your extruder. If when you hit extrude, you're actually ejecting the filament, flip it. So this will all be dependent on your motors. And if you change motors, these may change. If you change steppers, this may change. I believe all these are different if I put 5160s on. Why? I don't know. We don't need any of this. We don't need any of this. But here's a section that we definitely do need. And we're at the halfway point, which is awesome. And the rest of stuff is really easy after this and the next section, which is bed leveling. So XY bed size. So we have a 250 by 212.5 workable area on a Prusa printer bed. How do you know this? You can measure it. You know, I have an artillery sidewinder that's 310 by 310. That is the usable area. You will find out the hard way too. If you set these values too high and your nozzle crashes into something, yeah, it's because this value is too high. Because again, like if you swap to a Hemera hot end, you might lose some X and Y axis based on your printer's design. Technically, your Ender 3 is a 235 by 235, but it's limited in firmware to smaller because of those bed clips that are holding the bed in place. So you can actually change this to 235, 235, and you actually get more printable area, which is awesome. Your min positions and max positions. This is a complicated area that I still haven't figured out fully because sometimes it works, sometimes it doesn't. I just know on the Prusa, the min position is actually -4 on the Y. So if you look at the Prusa bed design, there's an area it has like 250 by 210. And then it goes into the bed a little bit and does that little stripe, the purge. That's an area it says it can't print at. And this is just that area it can't print at. So it knows that 00 defined by 250, 212 is incorrect. You actually have a little bit more room to mess with. If your nozzle, when you center the nozzle on the bed somewhere, it's off, you can change these. Basically, I am not mastered this stuff because when I change these things, sometimes they do what I want, sometimes they don't. I just know on this printer, it's -4. Please refer to your pre-made configurations by Marlin to figure these out if you're having issues. This is smart. Our max positions are the max size of the bed, so 250, 212.5. And our Zmax position is going to be 210. On that printer, I have a Volcano, so it's actually 202 millimeters. How do I know? The Volcano takes up 8 millimeters more space than a standard E3D V6. So I just subtract 8 millimeters from the actual max build height from a Prusa. So that's good. This is it. So if I had my Sidewinder, this would be 400. If I had my yellow and black printer over there, the Abrams printer, that would be 220. If I had Prusa Mini, that'd be 185, and these would be 180. So again, it's just when I home X, I see the extruder slam to the left, then back, and Y. That is the correct behavior, and that's in configuration advanced.h. So basically, that's called the I don't want to get into it section. We'll get into that. We'll explain why on tomorrow's video, which is configuration advanced.h, and how sensorless homing works. We do have sensorless ends. We do want sensor software end stops, and we do want to define the software end stop menu. Basically, there are digital end stops. So basically, you can't go past this 250 with this enabled. So if I disabled the end stop on the X, it means I can keep spinning my wheel beyond 250 if I wanted to. If I enable this menu, I can disable them from the menu. So if there's something I want, if there was a reason why I wanted to go beyond that, I could. So like, let's say you just booted up the printer and it won't let you move the Z. You can disable the software Z end stop and move the Z lower. It's kind of neat. Excuse me. Filament runout sensor. We have one of these. How to get these sensors working is going to be different for everyone. I know how the Prusa one works, so I'll highlight it when I did that. Runout inverting, you'll have to mess with this, but on the Prusa, it's true for the inversion. Basically, when the filament is inserted, the end stop is triggered. So it's inverted. Basically, the logic is inverted. So filament inserted enables or actually turns on the end stop in the extruder, telling you, hey, by the way, there's filament in here. So we need that. We need to set that to true. Now the opposite would be, let's say our filament sensor, if we left this to false, that means if the filament ran out, it would turn on the sensor. That's the opposite. So this one enables the run out sensor when the filament's inserted, and then it opens the switch when the filament is broken. It'll run the M600 script, which is basically the eject. So it's going to move and purge and remove the filament. And I like to define a distance of how much it actually begins to start doing this. So this is what I call the safety measure. So let's say there's an error and the end stop that's inside of your extruder, or if you got one on your chirality board on the outside, and it thinks just for an instance, like a wire is slightly loose and it just clicks, it'll automatically cause the filament run out and you'll get a false positive. I like to do a 2 millimeter run out distance. Now this would be much longer on a printer with a Bowden, but on my printer with a direct drive extruder, basically what I'll do is the end stop will trigger inside the hot end, telling you, hey, the filament ran out, but it'll run for 2 more millimeters just in case it's not a false positive. And with those 2 millimeters run, if it's still open, it'll then enforce the M600 filament runout script. So that is your magic. That is how I like to set it up. So basically, it's just a safety switch. Like maybe there was, a wire got a little jiggly, or there's a small break in the wire. Those small breaks won't cause a physical run out script to happen. It won't actually move the nozzle, stop printing, move the nozzle over, eject the filament, and wait for you to enter new filament. It'll be like a blip and be like, fine. With this safety feature, it'll blip, wait for you to print 2 millimeters more. If it's still off, it'll then trigger the M600. We're good. These values, again, will change depending on how yours is set up. My filament runout sensor is very close to the extruder gears. So on a Prusa style hot end, if this value was 5 millimeters, you might actually make it move so far beyond the extruder gears that it can't eject the filament, and now you're really screwed. So take that into consideration. Your setup matters. Bed leveling. This is going to be the most complicated section of them all, besides motors and pulley sizes and whatever. There are only 2 that you should ever use on a printer that has a bed leveling probe, and bilinear is by far the most common. UBL is my favorite. you should watch the Chris Riley video on UBL to get a better understanding. I have simplified this so much that it's just 3 menu items, and then you will never have to level your bed before a print for a long time. But bilinear is more common. Bilinear is just basically you're going to put a G29 in your start G code. It's going to probe all over the bed right before every print, and it's going to have the mesh, and you're going to print, and you're going to get a nice level print surface. UBL, you probe one time before doing anything, before even printing anything, before anything else. You're going to UBL, you're going to run it, it's going to probe the bed. You can print a test chart of how good the UBL did, so you can look at like how accurate it is. You can adjust each individual probe point. If one's too high or one's too low, you can adjust that. You can also do other fun stuff, and that's why I prefer UBL. It's basically the best of all worlds. So we're going to use UBL, and this is the first time me showing anyone UBL. Just know that we've enabled unified bed leveling. We definitely want the restore leveling after G28. So what Marlin does if you don't define this is if you home, it will basically delete the mesh. So your mesh isn't stored. What you can do technically is mesh on one print, and then after every other print, just not do a mesh, and it should still have that saved in EEPROM. Kind of neat. We won't do any debug leveling features. We won't do any of that. We will add the G26 mesh validation tool, which is basically, this is a printout of your mesh. So this works coincided with our UBL, where we will do a UBL mesh, and then we're going to print out a test, take a look at it, and if we need to edit anything, it's kind of neat. And we can actually change it on the screen or via menu. Watch the Chris Riley video. It is much more complicated than it needs to be, but it is correct. I also like to do this at 210. Blah, 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 blah. UBL, here we go. Everything is fine. We'll do one mesh inset. The amount of max points really depends on your board. 7x7 is far more than enough. I do 10x10. That's cool. If you have a fancier screen, definitely enable the mesh edit graphic overlay, but you don't have to. The other thing that we change here, thanks to Vert, is we set this to 0. But if we go through this, define mesh inset, it just says how far we inset from the mesh to start doing the mesh bed leveling. We've already done that all the way up here in our probing. Where is it? Here's our probe edge of 10. We don't need extra inset, so we just leave that at 1. The stock value is fine. And you can use one or the other. You can set probing the top one to 0 and set this to 10, whatever you want. This says 10 by 10. So again, it's copying whatever value you have here. So we'll have a 10 by 10 grid, which is 100 points. It's a little excessive. UBL mesh edit move Z. Yep, that's fine. UBL save action on M500. Correct. We definitely want to save our values as soon as we hit an M500. And the UBL raise when off mesh. So, yes, Marlin 2.0 for 8-bit can be done in VS Code. You would leave it as atmega 2560 for the environment. Basically, this is when the Z is off the mesh, it'll raise the Z to 0, so that way it doesn't mess up stuff. That's just a safety precaution. We don't have LCD bed leveling. We don't have bed leveling corners. So if you had like a CR10 and it's got those 4 corner adjuster knobs, you would define bed leveling corners. So you'd remove that, and boom, good to go. We don't need this. We don't need this. We can define a manual home position. So like on a Prusa, our manual home position based on Prusa is -3 and negatives, or not negative, 0.2 millimeters. So you can mimic, wherever you want the nozzle to home to. So 0 at the nozzle at 0, or the nozzle goes to 0 on the bed, -3 on the bed, and 0.2 on the Z. So this is where that would be defined. Z safe homing, yes, we want that. But I'm actually going to change these values. So what Z safe homing does is it normally would home the dead center of your bed. That way, if let's say senseless homing broke or something like this broke, it would move to the center of the bed and not like crash into stuff. I'm finding that 15 by 15. Oh wait, we don't need it. We just do 15. And 15 is a very safe point on most Prusa machines. So this will be the left-ish corner of the printer. So the nozzle will be at 1515, so it shouldn't destroy anything. Now here's our homing feed rates. These can all stay where they are. If you want it to home faster, you can change these values to whatever you decide. So 50 times 60 just means that it's going to be 50 millimeters per second, 4 millimeters per second. You know, we could do 60 by 60. You can do whatever you want here. This is fine. Validating home end stops is fine. We do not touch the bed skew compensation section. Yep, I know it's there. We'll just ignore it. I know we kind of went through mesh bed leveling a little quickly. I will do a section dedicated completely to mesh bed leveling, but we still got to make time to get through this configuration.h. We always want to define EEPROM settings. Always want EEPROM. That just means I can hit M503. I can look at the settings. I can then adjust them through Pronterface or whatever command interface I want. If that is not enabled, you can't change settings. Whatever's in your firmware is locked in there. So enable your EEPROM settings. This stays exactly where it is. This section I change. I do not print much ABS. And remember that section where we set the minimum extrusion temperature is at 180. I set my PLA to preheat to 190. Nope, leave that where that was. And I change it to 60 on the bed because that's where I typically print my PLA is around 200, 205, 210, and 60, 65. So these are good values. I don't print much ABS, so I just rename this to PET. You can name it PET G if you want, but this PET's fine. 240 is fine, but the bed can be 80. So, and you can name this whatever. You cannot add more. That is not part of Marlin yet. One day I hope that we can just be like, define preheat label 3 and just have something cool. Yes, I am positive about the Z-Home XY points. You can set it to 0, 0 if you want, or 1, 1. As long as it's on the bed, it's fine. So it's just saying move the nozzle to X15 and Y15, or the probe to X15, Y15, which is fine. It just depends on where your probe is. Yes, again, these are all changed. So whatever I previously had on my older firmwares is going to be changed. It's just basically the progression of testing and stuff. So where I've changed it and such. You know what? Let's go inside a little bit more, though. Let's go 30-30. That'll be even safer. It's just inside left corner. That way it's not going all the way to the middle of the bed and all the way back. Let's see here. Where were we? Oh, yeah. We're right here. We're at these temperatures. Maybe in the future they'll add, adding more preheat labels. For now, we get 2. I wish there was 3. Nozzle park. We want nozzle park. This isn't important right now, but you have to have nozzle park to do certain things. Like you have to have nozzle park to do M600 stuff. You have to have nozzle park to do things, to do filament changes like so M600 filament changes stuff. You have to have the nozzle park. You also have to have it enabled to do filament load and unload settings and stuff like that. You can also define where to park the nozzle. So it's saying to park the nozzle X min position plus 10, Y max position minus 10. So that's going to be, if we do the math here, Y min position is left plus 10. So it's going to be at X10. Y max position is going to be the back of the bed minus 10. So it's going to be at 200 millimeters. And then it's going to raise the Z 20 millimeters. Prusa style is actually the front right corner. So we're going to do the front right corner. So we're going to do an X max position. This is also a variant from before, minus 10. So front right corner, and Y min position plus 10. So we're basically flipping the logic. So this is going to move it to the right, and the bed's going to move all the way back so you don't bump into stuff. The way it does before, your bed would be forward and your hot end would be all the way to the left, which is cool and all, but that means you can bump into your print and stuff. This will shove the print all the way behind you. You can't mess with the print. You know, you're going to change your stuff and all that fun stuff. Good to go. Clean nozzle feature, we can't do that on our printer, but you could on yours. You could add like a little metal wire brush bristle setup, and you would define where that would go, and the stroke and whatever. It's all here. It's all in perfect English. We don't have that feature. I might mess with this on other printers where I can move. Basically, you have to be able to move the nozzle off the bed plane and have a place to put this object that you're cleaning your nozzle on. Really cool. If I make a custom printer, it's definitely going to have this feature because I like being able to clean the nozzle. So maybe attach onto the bed a little piece that has a bristle brush on it, and then I'll move the nozzle over there, scrape it a bunch of times, and then park the nozzle for the purge. Job timers, good. Print counter, I love this feature. So what the print counter does is tell you like how many prints you've done, how many millimeters of material you've printed, and stuff like that. I enable the print counter. Again, if you have a printer that has a very small board like a Melzi, you wouldn't start enabling these. This is completely like useless feature for most people. So if you're limited on space, don't enable it. Language, English works great for me. LCD character set, you can change this whatever. A lot of people, Western is more is some people change it to. Japanese is fine. It doesn't mean that we're going to be in Japanese font. It just means that's the way the ASCII characters are going to be done. Our LCD screen info style. So that is just the front screen. So we're using that 2004 screen. We cannot change this on something like the Ender, which uses a 12864. You can change this on our 2004. So if you want something, the Prusa style just has the temperature of the bed and nozzle at the top left, the Z height on the right, the percentage of the print on the right, the amount of time that's eliminated on the right, and stuff like that. On the classic style, which is enabled right now 0, it has like the XYZ position, which is basically useless. Where XYZ is during a print doesn't matter. So I've actually switched mine to Prusa lately. Classic on those, just there's useless information. You don't need the XY position at any shape or form while printing. This bugs people out constantly. Don't forget to define SD support so you can use an SD card if you have somewhere to put an SD card. Again, if you don't have a screen attached and there's no SD card on the board, you can't really define this. And it'll yell at you if you do it. So SD support. We do not have any of this SPI stuff. I do like check and retry, which just means it'll retry the SD communication if something messes up. I do not mess with the LCD menu items. For a 2004 screen, I have no understanding of how this works. I have tried pulses per step 4. I've tried steps per menu item 1. I've tried all of these, and it still moves just one item per step, and it always takes 4 movements to move 1 point if I adjust anything. So if I'm adjusting the Z offset, it still takes 4 turns to move one point. I don't understand what any of this does. It doesn't do what my brain thinks it does, so hopefully Keith one day will be able to explain it to me. But on the 2004 screen, you can do it this way, or you can do it this way, and I have seen absolutely no difference in how it works. Some encoders suck. So, yep, basically, some encoders suck, so you would change these things. What they do, I don't know. It says it should be increased for high resolution encoders. I've literally undone this and just had that. I've had them both off, and they all do the exact same thing. The Prusa ship with really nice higher end rep discount smart controllers, the 2004 screens. So we'll leave that. We'll leave it there. If your buttons are moving backwards than what you think, you can do this. So if you're spinning the dial and it's not moving the direction you want, you would reverse the encoder direction. It's right there. Pretty awesome. I have one screen that I have to reverse this for. It's the 12864 is backwards compared to the 2004 screen for me. I like the direction that I'm used to. You can reverse the menu direction and you can reverse the select direction. So left is, there you go, right makes it go left. So you can do whatever you want to customize your experience on your graphical display, which that's something that matters. If you're so used to one way of working, switching to a completely different one isn't helpful. I do define individual axis homing. This is great for troubleshooting. So basically just allow a menu where you can home X, you can home Y, you can home Z separately versus just a home button where you hit home and it homes everything every time. I leave speaker undefined because it will make noises regardless. Don't think that if you disable this, you won't hear a noise. You can even change the frequency and all this. I have not messed with it too much. Keith set some up that had some frequency changes, so you can change like how high pitched and how low pitched the sound is. Yeah, you can turn your speaker on so it always makes a noise. But like, let's say thermal runaway happens, even if this isn't defined, my 2004 screen still screech. Hey, what's up, Llama? And we're almost there. 2 more sections. Our screen is right here, the Discount RepRap Smart Controller, which is the 2004 screen. They have all these other screens, and they're already spelled out exactly what they are. Here's some LCD with I2C. Basically, they have a little controller on it that just contrast and stuff like that. Here's that older Vicky screen. Here's graphical controller. So here's that 12864. Again, that means it's 128 characters by 64 characters. So if you had a like Ender 3, this is the screen that you have. Here's that Vicky 2 I showed everyone that has the fancy screen on it. If you have touch screens and other crazy stuff, here's some OLED screens, some OLED screens. Everything's in here. We don't need any of them, but again, your hardware matters, and this is where that section would be. Oh, use the CR10 display if you have a CR10. So if I have an Ender, do I still use a CR10 display? Crazy guy. And scroll down and scroll down and scroll down, and none of this matters. And oh, NeoPixels. We're gonna have NeoPixels. So we define NeoPixels, and that will enable this section here. We have a specific type of NeoPixel. Our NeoPixels are WS 2000 something, etc., etc. Let's go find it. Let's go jump back over to me. Hey, it's me. We still got 35 people in here. We're peaking around 40. If I go to Amazon.com and I type in WS 2812B. Let me go ahead and screen share with you guys. Let's screen share. Let's stop the screen share, start the screen share, and whole screen, and allow, and Amazon. So they have all of these lights. We just have to make sure that they are WS 2812B LED pixels. I bought this one right here, the 16.4 foot section. It's black. It's amazing. It works. You can get a longer one. You can get this is the density. So this is a 150. Oh, you know, I might have gotten that one. I can't remember. So what you want to look at is how many pixels per how many pixels in that section. So this is 16.4 feet with 150 pixels. This is 16.4 feet with 300 LEDs per that one strip. So it's just basically the density. I believe I use the higher density ones, and 16 feet is a lot. You do not need that many feet. I still have plenty left after doing 5 printers and a mistake. 2 mistakes. So I still have enough to make a few more printers. But anything that has that model number should work. I specifically like these because they fit directly into my extrusion. So yeah, remember that the number of pixels that you use definitely changes some things. So let's go all the way back to StreamYard and stop that, and let's go share the screen, and we're gonna go back to VS Code, boom, and allow. And we'll go off of me, we'll go full screen on that. So these are specifically GRB. So there's only a red, green, and blue pixel on each LED. There's no W on them. So we would change that. The pin number, this also matters. Let's go back to screen share because this is very important for everyone. Let me go find it real quick. It's on my GitHub, github.com. So now that we're on my GitHub, let's take a look. Let me go back a step. We'll go to my GitHub. And no. Yeah, there we go. So let's go back to StreamYard and share my screen. Comes time to merge code to another Marlin. Yeah, Steven, I'll go over that. Not tomorrow, but third stream will be using WinMerge and stuff like that. Tire screen. Allow. So if we go to my GitHub and we go to the SKR beta here, and we go all the way to the wire guide, we need to know where our pin is for the NeoPixel. And it's pretty simple. It's marked NeoPixel. And let's see, where is it? NeoPixel. Pin 124 is 1.24 is the pin we need. So I'll go back to sharing the screen. And we'll go back to our configuration.h, allow. Make sure that's full screen, yep. So P1_24. So that is our LED driving pin. We don't mess with NeoPixel 2. The number of pixels matters. I fit 17 on mine, but this is depending on how many pixels you actually use. So that's how many LEDs are on your strip. So you would literally, I guess we're going to go back to me again, but we can go to me side by side. So you'd be like, okay, 1, 2, 3, 17. This is what I use. I use 17 pixels. And you can see the density and all that. So, and wherever you cut them, you can see that there's, oh boy, come on, focus. You wanted to focus earlier. There we go. So let me go right here. There we go. So you can see that you can actually cut. There's a little line, and you can cut them wherever you want. So you can cut multiple lengths off a 16-foot section, and you just need to know how many of these you're using for that. So when we go look over there, and we go over that little PC piece, we would put in number of pixels as 17. And we do sequential. I like to set the brightness to the highest brightness of 255. I like the startup test. Basically, it goes green, red, blue when you turn on your printer, so that way you know it works. And that's it. Yep, that's it. That's all we're gonna do in configuration.h. So we've done the basics. We've done showing you where the board is. We've done the naming, what thermistors to use, what sizes and shapes and whatever. All these things that we're doing are all things that we've kind of gone over. What screen, and it all goes back again. I hate saying it 100 times, but write down what components you have, because what components you have define what your settings are going to be in Marlin. And it is really just plug and play. It's literally just going through, picking and choosing, and adding features like what bed leveling mode do I want. And there's descriptions on what each thing is and all that fun stuff. So again, simple, easy stuff. It isn't in the beginning. It does get a lot easier the more you use it. Like, when can I use this edit graphics overlay. Most people are like, yeah, I want that graphics overlay, but that's dependent on your screen. I wish they had that here. But if I want to compile this, it's going to be like, error, you can't have this because your screen isn't a graphics screen. So usually if it says GFX, you have to have a full graphics screen. I mean, I kind of get that's what it means, but there's no like, if I go anywhere in here, it doesn't tell me that like GFX means full graphics display. But yeah, when we get to the WinMerge section, we'll talk about these settings. They are very dependent on your setup. Well, we know the default steps. These two right here we'll go through, and we'll also do some other stuff. So for now, we're good. Is there any other questions before we end this craziness? You've all held out this long, and there's still like almost 40 of you. TFT 3.5 screen is a hybrid touchscreen from Big Tree Tech that is, you can have it in touchscreen mode, or you can go into 128/64 graphics mode. And it's really awesome. I like it. It's just a really nice screen. It's kind of annoying, and I kind of only really use it in the 128/64 mode, but the touchscreen mode ain't bad. It just, customizing the touchscreen mode is a lot more difficult than I thought it was going to be. I'll be bugging Keith more in the future on that. Keep going. I'm here. Keep going. I compare code using WinMerge because I was having issues with Meld. I was using Meld, and for some reason it started freaking out on me. How do you change the default NeoPixel color? That's in configuration advanced.h. So that's going to be tomorrow's stuff. Yeah, there's going to be a lot of changes from my last commit. So I've really hunkered down and been like, how can I make probing faster? How can I make this more intelligent? So again, you can sit here and tweak Marlin as much as you want. So yeah, you can use the compare plugin in Notepad++. I prefer WinMerge. It's just so fast. Like WinMerge and Meld are so quick to go through. WinMerge is a lot faster than Meld. It's like, it's crazy how quickly I can go through and update my Marlin from my previous variant to my newest variant. Git rebase, yeah. Someone needs to teach me how to use GitHub. I'm still doing this the old-fashioned way of saving the firmware to my hard drive and stuff like that. So, yeah. I've kind of looked at it. It's Richard, is tough with MMU. I really haven't messed with it too much. The main person who used the Mosquito and the MMU is Joe Mike Tarantella, blah 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 blah. I can't remember. I can't pronounce his last name, but Joe Mike is the only guy that I know that I recommend when you need to like do Marlin, or not do Marlin, do Mosquito on the Mark III. That engineered, yes. Yeah, you can always add questions into the comments. So when you watch the video again and the comments open up, drop the questions in the comments. I'm not the expert. Like Chris Riley and Keith and Vert are all the experts. I've harnessed all of my knowledge from them and then have been like every day messing in Marlin since then to get to the point where not mess up completely and understanding certain things. Like some things I still don't understand. Like I don't understand the encoder stuff. I still like it. I've changed things and it doesn't do what my brain says it should do. And there's not really a like Marlin has really good documentation on certain things like S-curve acceleration and junction deviation and linear advance and different auto bed leveling methods and different probes. There's really good information on that. But then there's things like the screens. Like there's very little information on the screens. There's very little information on like how to add features that you want to add to it, like without like having to go to Marlin and asking them to make like I want more than 2 preheat temperature thingies. So I can't. Like there's just 2. Like I wish it was like a section to teach me how to add more. Like, oh, you want to add more? Like they don't have to do it. Just show me how. Like I wish there was that. I wish it was like encoders. Like what is Like where in like if this happens, this is how you change it. Like, I wish it was that for Marlin. Thankfully, there's like 4 billion amazing people that are way better at Marlin than me that can explain those better than I can. So I just have a voice and a YouTube channel. Yeah. And free time. So that looks like the questions have paused. So tomorrow, I think I'm going to try to do 2 o'clock tomorrow. So 2 p.m. tomorrow, I'm going to do, yeah, Chris, I wish, that's the thing. I like, with that encoder steps, like I'm literally, it takes 4 clicks before it registers 1 movement for Z offset. Like, I don't know how to change that. Like, I want maybe that'll learn, because I'm learning too. So maybe Keith will teach me how to do that. Like, yeah, so tomorrow on 2, I'll do a configurations advanced.h, so the adv.h. Yes, BL Touch is slightly improved. I can't make it go much faster than it is, because if you go too fast, the amount of error on a BL Touch, the speed at which it errors, the curve is much steeper. If Joe Mike just posted on someone's mosquito question like a couple weeks ago, and he's posted pretty often on there. I'll find him. I'll tag him and see if he can help. And then, yeah, so tomorrow will be configuration adv.h. So we'll go over all that. So it's probably 2 o'clock. I'll post that thing. Still hoping Jordan, wherever you're at, Mad Monkey, hope you've picked your time and then challenge the next person. So we can continue. Remember, this is a challenge. Thanks to Alien3D.us, Josh. He was like, I wish more people would do classes while everyone is in this, situation where we have all this free time to watch stuff. So the goal now is to keep challenging the next person to do a video. So since I'm doing one tomorrow, I'm going to challenge another person to do a video today. So once I put that time in, but I want to see that P2PP program. So, yep. On that note, Chris is passing out. He's gonna go get some. What time is it? 6:30. Yeah, he's gonna get some food. Maybe he'll stream later, some FDM stuff. Maybe he'll go play some games. He doesn't know. But thanks for coming in here. Enjoy. I'm gonna be putting those. So I'm like trying to bug Jordan to like just pick a time and challenge. Like, you can't slow it down. You got to just keep pushing people. Like, today's what? Monday? Tuesday? Today's Tuesday. The longer it takes, man, the next person that's doing a video is going to be like Friday. Like, that's just boring. I'd love to see like one day where it's like noon to 10 o'clock. There's videos like all blocked in. So, all right, everyone have a good time. See you later. Thanks to Keith, Vert, Chris Riley. Those guys are awesome for getting me to where I'm not a complete bumbling moron on Marlin Firmware. And then Josh, thanks for calling out all the YouTube creators for not doing more classes and helping people learn new stuff. So next challenge coming. So I will pick my next time and challenge the next person. I got to figure out who I'm challenging to put on a YouTube show. So good night. Happy modding. Stay out of trouble. We'll talk to you all soon. Goodbye.